Let us configure router 2 as a DHCP server, serving IP addresses for devices on network 1 here, and serving IP addresses for devices on network 2 also. So let us bring in our text editor with the configuration. You will find the configuration on GitLab. I will post a link to the repository in the comment section. Here we have the full configuration. I'll scroll down so you can see it all. We have the interfaces. We have routing options for the networks over on router 1. We have policies, and the policy says that in the trust zone, all interfaces should be able to reach all interfaces. In the trust zone, we have G002, 3, and 4. So that is the full configuration. The new part, or system services DHCP part. This is where we configure router 2 as a DHCP server. We have two address pools. We have the 192.168.12.0.24, which is our net 1 that we have documented over in our network diagram. And we have the address pool 192.168.13.0.24, which is our network 2 that we have drawn in our network diagram. We have configured the lowest address on network 1 to be .50 and the highest address to be .60. This means that router 2 will hand out, for example, to PC3 an IP address that will be between .50 and .60, for example, .50 or .55 or whatever. We're going to configure a DNS server to be handed out to all devices on net 1, and the DNS will be pointing at 8888, just because it's easy to remember. All devices on network 1 are going to be configured with a default gateway address of 12.1, meaning that, for example, PC3 will have the 12.1 IP address as its gateway. Finally, we are setting a lease time of 60 seconds. I actually think I will change that right away to be 600. And I have seen troubles with only 1 minute. The lease time is the time that each device, for example, in this case, PC3, will have the handed out IP address available before it has to release and renew its IP address with the DHCP server. So these are all the settings for net 1 that we will be doing here. The settings for net 2 are here, and they are very similar. Let's bump this up also to 600 seconds. This is all it takes to turn router 2 into a DHCP server for the two subnets, net 1 and net 2, as illustrated over in our network diagram. Let us bring up our putty terminal to get our configuration into router 2. Bring our configuration out of scope. Let us bring up putty, router 2. And our configuration is in router 2 now. Let us bring up Workstation to see that our DHCP server is working. Right now, PC3 is set for static IP, the profile listed in the top of the profile list here. Let us edit connections. Let us create a new profile for PC3 using DHCP. I will call that profile my DHCP. It's for IPv4. By default, the method chosen to get an IP address is automatic DHCP. The options are listed here. So we will go with automatic DHCP. Save that. Choose our brand new DHCP profile here. We saw briefly that we successfully got an IP configuration. Let us bring up our configuration again. We see here that PC3 has got the IP address 192.168.12.50. And if we look up here in our DHCP settings, we had expected an address in the span from 50 to 60. So this is exactly right. So PC3 acquired an IP address from our router 2 DHCP service. On Xubuntu, we can conveniently check our DHCP received IPv4 settings. We have our IP address. We have our default gateway. We have our DNS server. We have our subnet mask. So this is an easy check of our DHCP received IPv4 settings. Let us check out over on PC4 also. PC4 is already set to DHCP. Let's check the IP address and our configuration. We see here that the address is not within the expected span. We can see down here that the address is going to be renewed in 53 seconds. So we can wait for that, or we can actively go in and there we have it. We have a new address that was handed out by router 2 DHCP server, the running DHCP service. Remember that we changed the lease time to 600 seconds, and we can see here that the lease time has been bumped up to the 600 seconds and already counted down to a release in 593 seconds. What about this setting, the name server? How do we check that that is correctly set? One way to do that is to use the command line tool for the network manager. Network manager, CLI. There we go. The DNS configuration is correctly set to 8888, being requested out on ENS33 over on PC4. ENS33 right there. To exit, press Q.